Hello, hello everyone. Welcome back to my channel. I hope everyone is doing great. Let's solve ninth problem of dynamic programming study plan, which is unique paths 2. The problem statement states you are given an m by n integer array grid. There is a robot initially located at the top left corner. The robot tries to move to the bottom right corner. The robot can only move either down or right in any point of time. An obstacle and a spaces are marked as 1 or 0 respectively in the grid. A path that robot takes cannot include any square that is an obstacle. Okay, if there is an obstacle, a robot cannot take a path which includes an obstacle. Okay, return the number of possible unique paths that the robot can take to reach the bottom right corner. Okay, so let's say you are standing at a grid I comma j and you want to reach the bottom left corner. Okay, if you are standing at this particular grid I comma j, and what all options you have two options, either to go right or to go down, right? So let's say we have a function called f of I comma j, which will tell me the total number of paths to reach from I comma j till m minus 1 and n minus 1. So we have two options, either to go down or to go right. Okay, the paths, we have options like or this or that, so we have to sum up the results which are coming from both, right? So if you go downward, that means I will be go to I plus 1 comma j cell. So the answers coming from I plus 1 comma j grid and the answers coming from I comma j plus 1 grid, which is basically going the rightward direction. Okay, so this will tell me the total paths can be reached from I comma j to n minus 1 using these two sub problems. Now that we have written our recurrence relation, let's also write our base cases. Okay, if you have reached the end grid and if it is equal to, if the last grid itself is 1, okay, that means you cannot reach it. Okay, so if you have reached the last grid and if grid of I comma j, if it is equal to 0, that means you can successfully go to the particular grid. Okay, when it is 1, that means you cannot reach it. Okay, so if any one of the index, if it goes out of bound, that means, and if the grid cell itself is an obstacle. Okay, if you have an obstacle, from this particular obstacle you cannot reach it, so the number of paths will be 0 in this case. Okay, so let's try to look at the code. Okay, this is the same implementation of our recurrence relation. Okay, if I have reached the end grid and if the grid itself does not contain any obstacle, then I can reach over there. That means I can consider it as a valid path, or else I will be returning 0. Or if I have exceeded the boundaries of the grid, or if there is an obstacle in the particular grid, I cannot reach the destination, so this will be 0. Okay, now my answers will be coming from these two sub problems. Okay, see, if you draw the tree diagram of your recurrence relation, you will notice that there are certain problems which will be overlapping. Whenever we have overlapping sub problems, we don't need to recompute them again. We can use dynamic programming. So that is what I have done. I have defined a 2D array dp which is of size m by n. Okay, if the answer to the sub problem is already computed, then I will be simply returning it, or else I will compute the problem and store it. Okay, and I will be reusing it in the future. Okay, if you try to submit this approach, all the test cases will be passed and it will be pretty efficient solution as well. As you can see, if you analyze the time complexity and the space complexity, time complexity is big of m into n. The reason being, we are trying to compute all the dp states of m. We have m by n. Okay, so we are filling all this dp 2 by 2 matrix, so that is the reason we are having a time complexity of m into n. And what is the space complexity? Space complexity is the extra space required for our algorithm, right? So we have used additional space of m into n again, so the overall space complexity is also big O of m into n. In this approach we have solved using recursion, right? You can also solve it using iterative fashion, which is bottom up approach, which I have mentioned over here. Okay, I will also explain it. For any given state, it is only depending upon its right value and its down value. That means if the states to the, if I'm standing at a particular gate, if the states to the next row is already computed, then that is well enough for me. So I in the end I only require one DP array of size equal to the number of columns, and if I try to compute the answers in the reverse fashion, then that should be enough for me. Okay, so that is what I have done in the bottom up approach. I have defined a 2D DP array of size n, which is the number of columns, and I am trying to go from m minus 1 row all the way to the 0th row, and also in the columns I am computing in the fashion of n minus 1 to 0. Okay, so that is what I mentioned over here. So if the particular grid contains 1, that means there is no way I can compute the answer, or no way I can reach to the destination cell. So my answer, I will override the answer to the current cell will be 0. If I am in the last row, then my all the answers will be coming from its right cell. So dp of before that let's look at, if I'm standing in the last cell, if I'm standing in the last cell, okay, if the cell is basically 0, that means my answer will be coming as 1. Okay, if other than these two, if I'm standing in any particular row, answer can come from down or answer can come from right. Okay, the answers to the down is already stored in the dp of I. Okay, because we are computing in this fashion row by row, so answer to the previous row is already computed and stored in dp of I, right? Now answers to the right, answer to the right can come from dp of I plus 1. If we are in the last row, if I am in the last column, there is no way I can get the answer from the next cell. That is the reason I am setting it as 0. If j plus 1 is less than n, then only answer will come from its next cell, or else it will be 0. So the overall answer to the current cell will be down plus right. Okay, in the initial only I have just validated if the last grid, if it is 1, that means there is no way I can return. So stay here itself, I will be returning 0, and else I will be computing this algorithm. As you can see, we are manipulating our DP array in the row by row fashion and in the column fashion as well, right? So first we are computing the answer for the last row, and DP array was populated for the last row, and then we are going to m minus 1 row, n minus 2 row, and so on and so forth. Again in the each row we are computing answers in the fashion of columns from n minus 1 to 0. Okay, if you submit this problem, this will also be efficient solution. This will be even more efficient than our recurrence top down approach. Reason being, we are only using big O of n space here. Okay, the time complexity will still remain same because we have to process each and every cell in our grid. So the time complexity will remain as big O of m into n, and the space complexity is big O of n. Okay, I will be posting the solution in the description. Feel free to check it out. I will be posting in Java, JavaScript, and Python. If you are coming from any other languages, then you can feel free to check out the solution. If you like the explanation, hit the like button, hit the subscribe button, and don't miss to subscribe to my coding channel. Okay, thank you.